Hey guys, welcome. We're gonna do our study guide. Let's do it. Okay, so first thing, translate 5 units to the left and 5 units down. So going left is gonna subtract from here. So I'm gonna get -4 and then -5, so that's a -9. And then 5 units down is gonna subtract also from 6, so it's gonna be 1. Number 2, rotate counterclockwise 90 degrees. So our rule for counterclockwise 90 is -y comma x. So I just get to flip-flop these, -6 and 3, and then I take the front one, change its sign. So it should be +6 comma 3. Rotate clockwise 90. So clockwise is y comma -x. So again, I highly recommend remembering these ones. And so again, we're just going to flip them, and the one in the back is going to change its sign. So it's -6, -3. And then rotate 180. This one's really easy. We just change the sign. So that's going to be +5 and -8. I would graph these and double check to make sure it looks like it is doing the right thing at all times. But for the sake of the video, I just want to make sure you got the right answers. So hopefully I'm getting them correct. A is 2, -10, reflecting over the y-axis. So we do have a rule for this. When you reflect over the y, the x changes its sign, so this actually becomes -2, -10 when you reflect over the y. When you reflect over the x-axis, the y changes its value, so that's -3, +8. The y equals x line, which is really convenient. You just flip-flop them, so that's 3, -7. And then y equals -x line is going to be flip them and change signs. So that's -3, +7. All right, number 9, it says 6, -4 is reflected over the y equals -2. So we'll go to 6, 1, 2, 3, 4, 5, 6, down 1, 2, 3, 4. So there's D. I'm reflecting over the y equals -2. So remember, y equals -2. I got a -2 on the y, and then it's going to be a nice horizontal line. And to reflect over a horizontal line, it's pretty easy. We just want to count to the line, 1, 2, and then go up 1, 2. And so there's my D prime at 6, 0. So the difference between a rigid motion and non-rigid motion, explain. I'm just gonna speak. And so basically we're going to, sorry, I got lost in my thought. Rigid motion means our shapes are going to be congruent and the same. Non-rigid motion means the shape would change. So if I rotated something and it became from a square to a circle, that'd be non-rigid. Or if the square got bigger or larger, that'd be non-rigid. But if the square stayed the same shape and size, then it would be rigid motion. We'd call those shapes congruent. Number 12, perform a sequence of transformation that slides up 6 and reflects over the y. So we start at -3, 1, 2, 3, -2. So there's my first point. I'm going to call it A, so I don't get lost. So I'm going to go up 6 units. 1, 2, 3, 4, 5, 6. There's A prime. And then I'm going to reflect it over the y-axis. So since I reflected over the y, I'm going to count 3 and then 1, 2, 3. And there's a double prime, and that's at 3, 4 for my answer. All right, this next one I'm using the table to figure out my rule. So I'm going from -2 to -6. That sounds like I'm subtracting 4 from the x, and then 1 to 0 I'm subtracting 1. So x minus 4, y minus 1. If I look, that rule holds the same. 6 minus 4 is 2. -1 minus 1 is -2. 1 minus 4 is -3. -4 minus 1 is -5. So that rule will work. X minus 4, y minus 1. And then our new one is going to be -1, 3. Write an algebraic rule for coordinate notation of a translation that moves 5 units to the left. So that's going to be x minus 5. I did not mean to put that parentheses there. And then 6 units up, y plus 6. Cool. Okay, write the coordinates of the vertices for triangle ABC after reflection across the y equals -1, graph the preimage and the image. So if we have the preimage here, -3, comma, +2. Oh, that's -3, +2. That's over here. That's A. And then we have -1, 6. 1, 2, 3, 4, 5, 6 is C. And 6, 6, 1. 1, 2, 3, 4, 5, 6, 1. Oh, that's +6. See, Mr. Smith's got to look carefully. 1, 2, 3, 4, 5, 6, +1. And that's C. This is B. Okay. There's my shape. And it's reflecting over the y equals -1. So here's -1, and I'm going to draw that in. We just have to count. That's 2 away, so 2 away is C prime. That's 1, 2, 3, 4, 5, 6, 7 away. 1, 2, 3, 4, 5, 6, 7 away. That's B prime. A is 1, 2, 3, 4. 1, 2, 3, 4. And there we go. And we can go ahead and label those points at 3, -1, 2, 3, 4, 5. So -3, -5. This is -1, 1, 2, 3, 4, 5, 6, 7, 8. And this is at, I believe, 6, -3. Oh, it already has parentheses. There you go. Rotate 90 clockwise and reflect over the x-axis. Label and graph both the transformations. So 90-degree rotation clockwise is y -x. So the easiest thing to do would be to label A, B, C, and D first. So A is at 1, 2, 3, 4, 5, 6, 6, comma 7. -6, 7. D is at -7, 3. B is at -2, 6, and C is at -3, 2. So we're going to flip them and change the back ones. So that's 7, 6. That's going to be 6, 2, 2, 3, and 3, 7. Just applying the rule quickly. Quick announcement.
Gomez, please come to guidance.
Okay.
Edwin Gomez, please
right.
come to guidance.
Perfect. So let's plot these. So we're at 7 and 6. That's going to be A prime. 6, 2 is B prime. 2, 3 is C prime. And 3, 7 is D prime. One of the ways I'm counting quickly is I know that this box is 8. So instead of counting 8, I'm counting 1 back to get to 7. So I can see here AB is rotating 90 because those two right there look like they're going to meet at 90 degrees. So that looks good. It went clockwise this direction, which also looks good. Now I'm going to reflect over the x-axis, which is right here. And so I can apply the rule, which just means the y is going to change to become negative. So 7, -6, 6, -2, 2, -3, and 3, -7. So D prime is going to be, or D double prime is going to be here. C is going to be double prime there. B is going to be right there. And A is going to be right here. Notice my figures are all congruent because this is rigid motion. Cool. Reflect JK over the y-axis, then rotate 270. So the y-axis is right here. So pretty easy to do to flip. And by the way, this is the wrong letters. So that's okay. But L is going to become over here, L prime. This is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's J prime. And then K is all the way over there. So we're going to go K prime. So there's my shape. And we want to write that. So L, J, K, and L prime, J prime, double prime over here, and K double prime. All right, we got to keep it moving. So L prime is -1, 0. j is going to be at 1, 2, 3, 4, 5, negative 5, 7, and this is at negative 8, 1. We want to rotate 270 clockwise. So our rule for 270 clockwise is actually the same as 90 counterclockwise. So it's negative y comma x. So we're going to change these, and this is going to become 0, negative 1. This is going to become negative 7, negative 5, and this is going to be negative 1, negative 8. So if I'm here clockwise, I should end up down here in the negative, negative category, which all these are negative, so it looks pretty good. So 0, negative 1, there's my L prime prime. Negative 7, negative 1, 2, 3, 4, 5 is J prime prime. And negative 1, negative 8 is K prime prime. That looks pretty good. Reflect and then rotate into position. All right, number 19, write a rule for the transformation below that maps the preimage to the image. This looks like a slide, so we're just going to go left 1, 2, 3, 4, 5, 6, 7, 8, 9, and then up 1, 2, 3, 4. So that's going to be x minus 9, y plus 4. Basic translation, no reflection needed. All the C, D, E, F are in the same relative position, so we can just slide it in. On the back, identify the line of reflection. This should be pretty easy. It's right there. Right in the middle is what you want to find. It's hitting x at 1, so the line's actually called x equals 1. Write a sequence of 2 transformations that will map the preimage onto the image. So I would recommend just getting a slice of your patty paper and drawing the coordinates or y and x axis. Then draw your figure. Label your points because where the points are matters. And then we're going to try some different things. So I can see right now M is in the wrong spot. I could try reflecting this, but if I reflect it, the L and the M end up in different locations. Like L's on the left, but M's on the right, so that doesn't work. So I'm going to try rotating it. So that's 90, and this is 180. Okay. So it looks like it's in the right position, but I just need to move over 1 to the left and then down 3, and I'll land right on it. So it looks like rotate 180. I said left 1, that's minus 1, and down 3. So it's a rotation and then a translation. Okay. And then real quick, factoring. So factor this. This is a difference of squares, so that's x minus and plus. Okay, this one we have to divide everything by 2 first to get 2, and then x squared minus 7x minus 44. And if we x factor that, we get negative 44 and negative 7. That looks like it's going to be 4 and 11, and that's going to be a negative 11. So we get 2x plus 4 and x minus 11. Again, we didn't have to solve for those because it wasn't set equal. This one down here is a pretty trick one, but we have to do 5 times 30, which is 150, and then it has to add up to negative 23. So, because we can't divide a 5 out because 23 is not divisible by 5. So if we look at all of our factors, let's see, 4 doesn't go in, 5 goes in, 30, obviously we just did that one. 6, does 6 go in? I think that one does. 25? Is it 25? Yep. 7 doesn't, 8 doesn't, 9 doesn't, 10 and 15. I don't think, does 12 go in? Nope. Does 13 go in? And does 14 go in? No, so we've exhausted all of them because then we hit 15 over here. So none of these are going to add up to 23. If I add or subtract them, this will make 25 or 5. This would be 31 or 19. That's 25. And then they get way too big. So this is not factorable. Doesn't mean it's unsolvable, but we'll get there. You can't factor it and solve it, I'll say that. And then this one, we just do 45 and 14, which should be 9 and 5, I think. 9 times 5.